Today's lesson is on comparing dot plots. We're going to talk about describing the shape, the spread, and the center of your dot plot. So what exactly is a dot plot? You learned about this in sixth grade, so it should be familiar to you. When we make or view a dot plot, it's displaying our data graphically, and it's using a small dot for each of our data pieces. We organize our data points from least to greatest, and it's represented on something that looks like a number line. We can describe the shape of our dot plots based on the way the dots are laid out on the number line. There's three different ways that they can be described. And as you move up in math, these will be called different things. But right now in seventh grade, we're calling them symmetric, skewed right, and skewed left. As you get older, you'll talk about the shape, specifically about those, how they're bell shaped or not, and what they mean. But for now, we're just going basic. So the symmetric shape, um, it is either shaped like a bell with the arch at the top, or a bell with the arch pointing at the bottom and the higher ones on the sides. But here, our example of symmetric is we have a defined center, and it looks the same on both sides of our center points. Then we have skewed to the right. So when we have skewed to the right, it is very confusing because a lot of students think that being skewed to the right would have the clumps to the right, and it doesn't. When something is skewed to the right, we're talking about that there's fewer data points to the right of our dot plot. So what is skewed to the right? There's a tail. If you look here, I'm going to use my mouse. The tail of our dot or our data is actually pulled towards the higher numbers to the right side. So that's why we call this skewed to the right. Skewed to the left, the data is clumped on the right side, and the tail is pulled to the lower numbers towards the left. So those are our shapes of our dot plots. Then we have the spread in our center of our dot plots. When we've already done our lesson on variability of data. We also can use variability of data when we're describing a dot plot or any kind of graph. So the way we're going to represent that is by the range, where we take the largest value and subtract the smallest value to see how our data ranges. Then we've got median and mean, and that's going to represent our center of data. When we use the median and the mean, we're going to use it in specific instances given the type of dot plot, or I'm sorry, the way the shape of the dot plot is. So if our data and our dot plots are skewed either to the left or the right, the median is going to be the best. The median is going to be the best representation of center for that. And then if it's symmetric, then the mean is going to be the best representation of center for that. You can use median or mean. It really depends on what the question's asking you. But if you're given the choice, you would choose median if skewed and mean if symmetric. Okay, so here we go with example one for comparing dot plots. You see data up here at the top that represents the number of minutes that each student in our given classrooms, each student, how long it took them to travel to school. So we have classroom 434 and classroom 425. I'm going to go ahead and make the dot plots for you as part of the example, just so that you can be reminded from sixth grade how to make a dot plot and what exactly a dot plot is. So our dot plot should have will have a dot for every single data point. So what I'm doing right now is I am taking each of my data points from room 434 and I am placing them on the dot plot where they belong based on their value. So I just read across to myself all 10 of these values and I plotted them all 10 dots on my dot plot. Yes, I had more than one 4 in my set of data, so I have more than one dots over the 4. I'm going to do the same thing for room 425. Okay, so I had 10 pieces of data. I should have 10 dots on my dot plot. So now that we have our dot plots constructed, part of, or the whole purpose of this lesson is for you to be able to compare the dot plots. We need to be able to describe the shape, the spread, the center, and then compare them. So let's talk about the shape. So you saw just before this example, you saw that our shapes could be symmetrical, they could be skewed to the left or skewed to the right. We can also have a non-pattern like shape. So it's not skewed and it's not symmetrical. So we would just say it's not a pattern. The no pattern is what my classroom 434 dot plot is going to be. It's definitely not skewed, clumped to the right or to the left, and it's definitely not symmetrical. So this would have no pattern to it at all. If you look down at room 425, this is an example of a symmetrical dot plot because we have a pretty defined center and it looks the same on both sides. So we have symmetrical, and up here would be no pattern. Since we are identifying this one here as symmetrical and then we have no pattern, our measure of center that we're going to find is going to be the median. We would be finding the mean if we were skewed to the right or the left to take account for that outlier. But with our median, since our data is pretty evenly spread, the median is going to be our better measure of center. So if you recall, to find our median, we want to take off the highest and the lowest and keep taking off those data values until we get to our center point. If there's not a center point, then we're going to take the two data values in the center and find the mean of those. So I'm going to take the lowest and the highest. I'm going to continue marking them off. And now I'm left with my two pieces in the middle. I have a 5 and a 7. So I have to find the mean, or what is in the middle of 5 and 7. So 5 plus 7 divided by 2. So that's 12 divided by 2. So my median here is going to be 6. Now I have at the bottom, if I'm finding my median, highest and my lowest crossed off, and I'm left with my 2 in the middle. I need to find the mean since I don't have a defined median. Most of you will just know if my 2 points are 5s, then my mean will be 5. If not, we can find the mean of that by adding them, finding the sum and dividing by the 2 data points. And that's going to give me a median of 5. So there's our medians. Let's find the range. So that's going to talk about the spread of data. How far spread out is it? So if we look up at room 434, we have our highest value minus our lowest value. So our highest value is 8, our lowest value is 4. So our range here is going to be a range of 4. So it ranges with a difference of 4 minutes from the person that has the longest bus ride to the shortest ride. Doesn't have to be bus, sorry, in class 434. In class 425, my highest is 7, my lowest is 3. That has a range of 4 also. So if we're going to compare, now we've found the shape, the spread, and the measure of center. We can compare these two. So I can tell by the medians, I wrote here in black and circled them, based on the median number of minutes it took them to get to school. It appears like the students in class 434 are going to travel further, and it looks like about 1 minute further than the students in room 425 when we're looking at our measure of center. And then the spread, they're both spread equally. So the person with the longest ride and the person with the shortest ride, there's only a 4-minute difference between them. And that's the same in both classes. So a dot plot really gives us a good look at how our data is spread out, and to see similarities. And that's what we're looking at in the shape, to see, are we looking at a big clumping to the left, to the right? We're going to see if there's any major outliers. And dot plots are easy to make and easy to read. So something good for you to know. And here we go. You're going to try one on your own.